All right. Hello, everyone. I okay. For regular viewers of this session, you're going to notice something is really off in that I'm going to be doing the intro. This is kind of weird. I don't know. So stay with me. You're not in some sort of a I don't know, some sort of a different parallel universe. It's really the K6 office hours. But so anyway, I am Paul Balogh. Glad to meet you, developer advocate here at Grafana Labs, and I am joined with my colleague Nicole.
Hi, I am the person that pushed Paul to do the intro. I'm still here, but I'm enjoying taking a bit of a seat back.
That's right. Yeah, from your undisclosed location, that's different than
Amsterdam in the
normal.
Netherlands.
Yeah. Okay. Yep. Yep. All right. Well, cool. And we're hoping that you don't lose your hotel connectivity. So we'll see. But yeah. And today, very special guest. We are joined by, and Dan, I'll let you introduce yourself.
Awesome. Well, thanks for having me. My name is Dan Mangum. I am our cloud lead over at Golioth. Golioth is an Internet of Things company, which is a very broad term, which we were talking about before the show started. But we focus in on making it really easy to connect devices, especially devices in constrained environments. And we'll talk a little bit today about what that looks like. Constrained devices to the internet, basically. So what we want to do is if you have a hardware and firmware folks at your company and you have cloud folks at your company and they work together to make your product, we want to make the relationship between those two domains as simple and straightforward as possible. We like to say that we talk firmware to the firmware team and we talk cloud to the cloud team. And we'll look at our platform today and kind of see how that works.
Awesome. It's kind of, I don't know, is there going to be some sort of like a new DevOps term, something?
We were talking about some of those, and IoT is already very buzzwordy. So I think we're hesitant to introduce too much of it. But I know some IoT companies are already using terms like device ops. One that I was throwing around with our team yesterday was fleet ops. So I'm sure we can come up with something, right? Maybe we'll spend the second half of this live stream today just focus solely on that. So.
It's just like ops all the things.
Exactly. Because it's like now, well, I don't know, DevOps is kind of like becoming available again, so you can maybe repurpose it, because I mean now the traditional DevOps seems like it's going platform engineering. So yeah. So,
you're getting the Twitter ads for it, or the X ads. Sorry for
it.
Who's still on Twitter? Seriously?
Yeah, right. The degenerates like me. So
oh, it's funny. But yeah, so well, Dan, so gives folks some of the background on this, that why is Paul in the hot seat, in the main seat here? Well, Dan reached out to me. They have some products that they're working on, and we have I don't know, we kind of go way back before COVID. I mean, it was you were back in St. Louis and all that, and then we had met at, what was it, HashiCorp user group, I think, the Hugs,
I think
the
so.
St. Louis Hug. But and then bumped into each other at a couple KubeCons and such, and and I know you were big in with what was it, Upbound and Crossplane. You were doing a lot of stuff. You had that you had your own YouTube thing going with the binding status, was it?
Yep, that's right.
Yeah. No, but yeah, so since you've moved on, so yeah, you already kind of mentioned Golioth. So yeah, give us what made you move?
Yeah, so back I was in St. Louis originally because I went to university there, and then stayed there for a few years afterwards. Definitely a big St. Louis fan. We'll take no St. Louis slander on this show today. But my wife and I moved out to North Carolina for her to go to graduate school. So I was working. I worked at a consulting company for a bit right out of school. Just for a few months. And then, like you said, I went and worked at Upbound, where we were working on the Crossplane project, which is a CNCF project, which is basically infrastructure management, or as we like to call it, control planes, managed by Kubernetes. So it's kind of like if you take your containerized workloads that you're orchestrating with Kubernetes, and they talk to databases, especially if or any infrastructure, but let's say databases, especially if they're running on the cloud, being able to have a single system for provisioning, and also keeping some of those like control loops and things like that in play, for making sure that infrastructure is continuously managed, just like your workloads. So that was a ton of fun. Got to spend a lot of time working on Kubernetes, working on crossplane, et cetera. But I've always really had this kind of deep passion for like moving down the stack, if you will. And I've kind of like my background is in computer science, so have not done a lot of formal hardware education. And one of the things that really attracted me to Golioth, one was kind of like the domain and the outlook on the problem space, which I already kind of talked about a little bit. But personally for me, it is really this like connective glue, right, between hardware and this cloud domain, which I had a lot of experience in. So it was a nice place where I felt like I could come in, and already we're a pretty small company, but we have some really high caliber hardware and firmware folks, as well as on the cloud side. So it was both a company and a direction and vision that I was excited about, as well as personally wanting to grow some of those like hardware and firmware muscles. So yeah, it's been a lot of fun. I've only been here a few months. Was definitely very big fan of Upbound and continue to support them, and they're doing great things. But it's been a lot of fun.
Yeah, that's cool. Yeah, no, I saw a lot of your social media posts and things where you're like, oh yeah, working with these RSC controllers or whatever, I don't know. And I'm just imagining you sitting at some table with a soldering iron and just going crazy, and I don't know, creating Raspberry Pi based Kubernetes clusters and things. I don't know.
Yeah, I've
It's
definitely I wish y'all could see my full desk here. There's just like hardware and a soldering iron right here, actually.
There we
Just
go.
Oh,
littered about.
awesome.
So.
Now, do you
Yeah.
have an oscilloscope too? That would be cool.
I do have an oscilloscope. Yeah, it
Nice.
is unreachable from my current location, but yeah. So I'm
I
building up the gadgets.
Nice.
I actually think it's really interesting that it's the whole Internet of Things space kind of goes in the opposite direction. Usually we want clients that are, that process things really quickly, so they have quite a bit of juice in them. But with Internet of Things, you're going the opposite way, where they have to be, in general, pretty limited in terms of capacity and power and processing capabilities. And as a tester, I know one of the things that is super important is the security aspect of them,
Mm-hmm.
because a lot of them are incorporated into your life.
Right.
And you may not think that it's super important that people know how many times you've opened the fridge, but like, hey, if someone gets access to that, now they know when you're home and when you're not home.
Yeah, absolutely. That's a really good point. And, I think coming into uh, the IoT space, which somewhat unfortunately, it's such a broad term. So it can mean everything from like very constrained sensors, in a field and a farm or something like that, all the way to pretty high powered devices that we have in our homes, right? That talk over Wi-Fi and that sort of thing. But you make a really good point around security. And one of the things I think I was kind of naive about is in the cloud space, we kind of, despite folks definitely getting security wrong from time to time, it's definitely viewed as a priority, right? And it's something that is an expectation. Well, when you're working with these constrained devices, you have limited physical resources, right? You can't scale infinitely. So you start to think about things a little bit differently. And we're actually going to see some of that today and talk about why it's important to load test our system in certain ways. But, if you spent the time and effort to produce a piece of hardware and it has specific constraints, right? That's a lot harder to change than software. So let's say you're getting to the end of, your development cycle for a new product that has hardware and firmware on it and talks to the cloud, and you run out of memory, right? You're not able to do something. What's the first thing people are going to cut? It's going to be security a lot of times, because the product can function without security. for some definition of function. I would say that it's not functioning if it's not secure. But it can operate, and it's an easy thing to cut. And there's also, when you're in those more constrained domains, a lot of the aspects of security and cryptography that we do when we're, talking over the internet, right, and encrypting video and that sort of thing, we take for granted because our machines can handle that. But when it's a more expensive operation, you have limited resources, those things start to get cut, and it does create some very misaligned incentives when it comes to producing these products, and also making sure folks are safe and protected from the things you enumerated there.
Yeah. Oh, yeah. I always think that the thing with the camera that feeds your dog treats and things like that, where you can do it remotely, and it's like I don't want somebody that just be able to give my dog treats whenever they want. I mean, it's
right. That's the
I don't want someone to be able to turn my lights off.
right.
Yeah. The I think especially the security kind of security system IoT, right? So if you're talking about home cameras and security systems and that sort of thing, you definitely want some security there, right?
Yeah.
So yeah.
But also, so I'm not at home, so I can say her name. I have Alexa in every room. Usually I'm
listening.
like, Alexa.
Right.
But there was one time last year where there were issues with AWS, and some of the Alexa servers, of course, are on AWS. And I kind of forgot where the switches were in my house, because all our lights are voice controlled. And so it was like, which switch does controls this light again? And it was just really odd. Another thing that has happened, it's not really a security thing, but once we were woken up in the middle of the night by the speaker playing something at full volume, and it's just that stuff is important. It is a functional issue. Absolutely.
Yeah, it's interesting. I feel like smart home is kind of the go-to when people think of IoT, mostly because it's more ubiquitous. Anyone could kind of have that. And interestingly, from Goliath's perspective, at least at this point in time, we don't focus too much on smart home applications, mostly because a lot of times, your Alexa is plugged into the wall, right? And it's, relatively big machine comparatively to some other applications. A lot of times we're dealing with things, and you can go to projects.goliath.io to see some of our reference designs, but things like tracking refrigerated food that's being, trucked across the country, some of the agricultural sensing things I talked about before, air quality, trash and recycling, those sorts of things. And it is very interesting to explore what the different requirements and constraints are, and what the impact is of an outage like you're talking about, and how that impacts people's lives. And sometimes, especially, in more kind of that utility space, an outage is unacceptable.
Yeah, that's pretty well though. What I mean is, so what kind of devices are you mostly dealing with in Goliath?
Yeah, so we have a number of devices in our docs that are specifically kind of tested against for our hardware in the loop. So we, instead of saying that we just support certain devices, though, we try to standardize a little bit more on integrating with various frameworks and RTOSs. So we work very closely with Zephyr, which is an RTOS that's hosted under the Linux Foundation. And not to use too many acronyms here, RTOS is real-time operating
Yeah, I was going to
system.
say.
Yeah.
RTOS.
If I do that, make sure to call me out to define those. So real-time operating system, which is one of these operating systems that runs on these more constrained devices. But yeah, so Zephyr can target a lot of different devices. You can go to the Zephyr docs and take a look at everything that's there. But a lot of times we're dealing with devices that have some cellular capability, because they're not, they might be in transit, or they're in a remote location. So I have some hardware right here. Let's look at this one. This is the NRF 9160 dev kit. So
this is like show and tell.
Yeah. I can. I have I don't know if you can see it. This external closet thing here. It's just full of hardware. So this is a chip from Nordic Semiconductor, and it's a cellular chip. So this is just an example of a dev kit. So this is much larger than the actual physical hardware that the customer would be building. But yeah, this is an example of, kind of a more constrained device that may be transmitting over cellular. But we also, folks are probably familiar with like an ESP32, STM32, any of those sorts of things. We integrate with a lot of different devices.
Yeah, because I know so hopefully everybody's kind of standardizing on different protocols and things. But I know that like way back, it was probably about 15 years ago. I think I was working in space with these with these smartphones that were just coming out.
Yeah.
And at the time I was in Java, and we had to do like J2ME, which was like really seriously lowest common denominator. Because at the time, I guess you could consider these kind of constrained devices. But I just remember having to do some things where we wanted to have these interact with things like, maybe a little like a receipt printer or something like that, where, somebody could on a form on a phone and then print off a receipt. And then because there's so many different manufacturers of all these different devices, it's like everybody had a unique SDK, and then you're trying to code for all this stuff. And I mean, so with things like with this Zephyr, is it kind of like standardizing somewhat so that there's not quite a million different things that you got to account for?
Yeah, I think that's spot on. Zephyr, especially in the past few years, has become more of a common platform to develop on. In fact, the board I was just holding up, Nordic, they kind of have their own distribution of Zephyr. So there's some chip vendors, right, that have gone that direction of saying like we are only going to support Zephyr, and that's kind of become a standard. So that's been really beneficial to a company like us, right, where we don't make physical hardware except for reference designs. We're just writing firmware that you include as a library into the firmware that you write that's going to go on the device. And so, it's been super useful. And I think the ecosystem is becoming less fragmented, but there is always folks that, especially a larger company might own the whole stack. And we do use standard internet protocols, one of them being CoAP, which I'm sure we'll talk about today. And so we say that, like you can choose your level of complexity, but you're never cut off, right? Because we are at the lowest layers using standards from, the IETF and that sort of thing. So you can always kind of like have an escape hatch.
Yeah. Well, and perfect segue into CoAP. So what is this CoAP you speak of?
Yeah, so CoAP, in the spirit of defining acronyms, which I'm sure we'll have plenty more of today. CoAP
is because these are constrained devices, so we can't use the full naming, right?
Right, exactly. Exactly. I don't know what the excuse is in every other level of computing, but we'll use that one here today.
There you go.
CoAP is the constrained application protocol. And I'm going to pop open some of my notes here so I can reference correctly. It's defined in IETF RFC 7252. So CoAP you can think of pretty similar to HTTP. And in fact, HTTP is referenced in the RFC. If you give that a read, it's actually fairly digestible. And basically what it's trying to do is bring kind of REST patterns into a more constrained protocol. So CoAP, like many application L7 layer protocols, can operate over a variety of different transports. But one of the things that makes it unique is that unlike HTTP, CoAP can operate over UDP. So UDP and TCP, right, are frequently the transports that we use in the internet. And so TCP is a connection-based protocol. So you form a connection and then you start transmitting over it, and it gives you a reliable transport to communicate over, so you can ensure that your packets will be delivered and they'll be ordered correctly and that sort of thing. UDP is connectionless, so you're basically just saying, hey, send it and see what happens. And so the value of CoAP is it brings up the decision of whether you want reliability or whether you need reliability or not to the application layer. So when you think about HTTP, you're reliable all the time, right? Because you're operating over TCP. Yep. If you're using UDP, you have no reliability. So you have to either introduce that at the application layer, or you have to say, I don't need reliability. So CoAP gives you that optionality, which is a really valuable capability, because you can say within a single application, these types of messages I need to be delivered reliably, and these ones I don't. So maybe let's take a good example. You may be sending logs from a constrained device up to a cloud platform that allow you to, troubleshoot in the case of errors. And you're okay with losing some log messages here and there. So having them deliver reliably, it's not super important. You actually don't want to waste battery power or compute power retransmitting that. However, if you're doing an over-the-air update, or OTA, as you'll hear it referred to a few times today, you are going to need all the bits, right, of that firmware image that you're downloading from the cloud. And so you want reliability in that. You can't afford to lose any. So if you don't get a packet, you need to retry. So that's really the core of the CoAP protocol. There's also a few different blog posts that we have. So first one is Life of a CoAP message, and it's on the Golioth blog. I think that might be in one I sent over earlier. And then there's another one called Why Golioth Uses CoAP. And both those kind of like break down exactly what's going on there. And folks are welcome to check those out for more info.
Yeah, and here I got some of those links too. It's kind of funny. We pass that information over LinkedIn, and of course LinkedIn is capturing every one of those links. I just can't say copy and then paste it in because it's going through LinkedIn. So thanks, LinkedIn, making it real easy for me here. But yeah.
Nice.
But yeah, so I'll be a little bit slow with getting some of that information displayed. But there we go. There's why Golioth uses CoAP.
Yeah. Awesome. Yeah. And folks can definitely check that out. If you just go to our blog in general, there's if you're interested in network protocols, these are some great posts, but there's also just a ton of other interesting hardware and firmware posts and great stuff to check out there.
Yeah. I mean, that hardware space that's huge. I mean, all these connected devices it's crazy. There's so many.
Absolutely.
But yeah, so I don't know. What do we go straight into the demo, or
Yeah, sure. Let's do it. I think I can start demoing, and then y'all can ask questions as you like, and we can go on any tangents as we want as well.
I like tangents. That's
Me
the way
too.
I operate,
I plan to be here all day, so I hope that's
you heard that here.
Oh, did we tell
day.
you? Yeah, this is a 24/7 stream. Surprise.
We are streaming to Twitch, so
right. Cool. All right. I'm going to start with just sharing my browser, and we can talk a little bit about some of the actual extension itself, and then we'll get into demo. So cool. We'll start over here. This is the extension itself. You can also find it, of course, in the K6 registry. I assume that lots of folks watching this are familiar with how K6 extensions work, but I'll talk briefly about it. Basically, K6 uses, and XK6 specifically, uses a library called Goja. Correct me if that's a mispronunciation. Okay, cool.
Yeah.
Which is basically a Go JavaScript bridge. So we at Golioth use Go a lot on the server side in our cloud products. And we have some nice libraries that we rely on there. And so what we want to do is allow for folks internally at the company and now externally as well to be able to write tests in JavaScript, this really nice, easy scripting framework that K6 gives you, and also use the other K6 libraries, while also leveraging these libraries that we use. So what we did is we took the Go CoAP library that we use. So you can see it here.
Yeah, and actually, if you could increase the font
Yeah,
there,
absolutely. Let
zoom
me
in
see
a
if I
little.
can.
You may not have noticed, but I'm a little old. It's
Or maybe you
Well,
just need glasses.
yeah,
Look at Dan and I. We're
you
the
know,
cool kids.
that's
yeah,
right.
right.
Well, yeah,
I would not be
my
able to do any of this.
bifocals. Yeah.
So Go CoAP is the library that we use through a variety of applications over here at Goliath. And basically, what we're doing here is just taking Go CoAP and using that Goja library and some of the K6 niceties, and wiring up the ability to create a CoAP client and then perform the usual operations. Like I said earlier, CoAP matches really closely to HTTP and RESTful semantics. So you're going to see those same kind of like get, put, post, delete methods that are familiar to you. And then we just expose those over on the K6 side through the JavaScript module that gets compiled and emitted here. So it's pretty straightforward. It looks like, using something like fetch or other HTTP APIs that you might use from JavaScript. And it's pretty straightforward to get going. So it was a really great experience. One of the things I kind of stressed when we were open sourcing it is there's not a ton here, right? 312 lines, kind of wiring things together. It's mostly just glue, which I think speaks to the value of the K6 tooling and the XK6 extension mechanism that makes it this easy to take something new and incorporate it.
Yeah, that's awesome. I was going to ask how was your experience with writing that?
Yeah, it went fairly well. I will say I am not the biggest JavaScript fan there ever was. However, I do obviously find it useful for being able to script these tests really easily, and not just in the load testing scenarios where we may have engineers writing it, but even from like a useful anecdote is once we started using this internally at Goliath, I was actually talking to a customer who was having some issues, and they kind of were like describing the scenario, and kind of like we were talking about earlier, a lot of our customers have pretty large fleets. And I was actually able to use this to quickly write a little script that simulated basically the behavior that their fleet was exhibiting. And we were able to work out what was going wrong on their end, but basically kind of like emulate that scenario really quickly, mostly because with K6 you can write these tests and then run them with a configurable amount of virtual users. So I can say I want to run it with one, or this customer who had hundreds of devices, I can say, all right, I want to run it with 200, and let's see how 200 devices behave in this environment. So it's really useful from that perspective. It did take a little bit of time getting used to like kind of the Goja semantics, and there's a couple of best practices that
casing?
yeah, that as well. There's also I think the probably the most confusing, or part that probably took me the longest, was just dealing with the observes. So I'll talk about this a bit more in a minute. But an observation is basically allowing a client with CoAP to say, I want to be notified of all changes to this object. And so that's a little bit different from some HTTP behavior there. But typically how that works with this Go CoAP library is you pass it, a callback function. And so getting this to work, being able to pass a JavaScript callback, which we can see happening here, being able to pass this in took a little bit of understanding of how that works. In fact, it was mostly spending time in Goja world and trying to understand that. But actually taking that and turning into some documentation is something that we hope to do to allow other folks to have a good time as well. It's also someone had put together this task queue library, which made it a lot easier to get that working. So That was probably the most complex, but overall, great experience. Cool.
So I'm curious, Dan, when you talk about testing, is it always like you said 200 devices? Is that normal? Do you typically, my perception is that when you're testing connected devices, that you would have very low payloads, like smaller payloads in general, and maybe higher volume. Is that right, or is that always the case?
It depends quite a bit on the domain. I think in general that intuition is correct. One of the things I think that's fairly interesting about a lot of these devices is a bunch of them will establish observations on like OTAs, for example. So they want to be notified whenever a new firmware image is available. So you could have something like, 10,000 devices come up and say, hey, we all want to be notified when a new firmware image is available for us to download. And we can look in the Golioth console here in a minute. Or actually, I'll go ahead and pop it open. If we went and looked over here and said, hey, we want to do a firmware update. I don't have an artifact here, but when you create a release, you basically select it and then you can start rollout. And depending on the tags that you apply to specify it, or just all of them, this is going to actually roll out to all of the devices in your fleet. So you could, in one moment, roll out firmware images to a ton of different devices, which incurs a lot of traffic. First of notifying them, and then all of them making the request to download that image. So there's some bursty patterns in IoT world. And then there's also just things like the ongoing logs. And some of the payloads may be larger if you're doing things like, sending image data or anything like that. So it's pretty wide and varied, which is another reason why we were big fans of using K6, because it allows us to write a test once and then simulate for different numbers of devices, different amounts of repetition, that sort of thing, durations, iterations, etc. So it's really important for us to be able to model a lot of different scenarios there.
The way that you talk about it as a fleet kind of makes me imagine it as kind of like a Kubernetes cluster, except hardware, where everything is the same. It's like you're pushing the same image to everything, but there are still individual differences.
Yeah, absolutely. I think that's actually a really good way to look at it. And, when you think about kind of like the pets and cattle distinction that you like to have with servers, it's interesting with IoT because you want to manage them like cattle, right? Because you want to be able to say, like, I want to update the fleet, not just I want to update device, XYZ. But there is, the nature of, like, you can't just have devices come and go for a lot of different applications. Let's say, you have, let's say I develop a product and you have one of them in your home, right? Like that device getting just cut off, like a VM going away in a Kubernetes cluster is not acceptable, right? So there are a lot of similarities from like a management interface perspective about what you want to be able to do there and how you want to be able to roll out new software. But you also need to be able to really drill down and get that introspection into single devices and get those logs off of them. But there is a whole lot of parallels.
Yeah, I know.
So Golioth is kind of like a Kubernetes then.
Sort of, yeah.
For little bits of hardware. All right.
Yeah.
That's cool.
It's almost like you own all the nodes in your Kubernetes cluster.
Right.
Though.
Yeah. All those devices are your worker nodes, and you're pushing out the updates.
Yep. It is pretty similar. Yep. Cool. Awesome. Well, I wanted to talk a little bit about some of the differences of maybe like how you generally think about like authenticating to a platform and that sort of thing. Because, I think a lot of uses of K6 are basically testing web APIs, right?
Yep.
And you may use a variety of different authentication mechanisms in that space. Usernames and passwords, API tokens, etc. Those could all be on the table. When devices are connecting, we're doing something a little bit different where we are authenticating at the DTLS layer. So instead of sending credential information from the application layer like you would with HTTP, we are performing a handshake with DTLS. So DTLS is datagram transport layer security. So it's just like TLS is to TCP, DTLS is to UDP. And that once again kind of like has to bring in some of those reliability properties on top of an unreliable protocol to be able to perform that handshake. And I think I also dropped the DTLS spec or RFC link in there, but folks can look that up. It's actually defined as a diff to TLS. So that's how similar it is. But there's some interesting stuff in there. Once again, that life of a CoAP message blog post goes through some of the interesting aspects there. But when you perform this handshake, there's really two different ways you can do it. So one, and we'll actually look at this specific device here, device one. One way you can do it is with what's called a PSK, or pre-shared key. And that's basically where you say, hey, I have this key. This is the identifier for it. So I'm the client saying that to the cloud, and the cloud says, oh yeah, I know about that key. And then you can use that key to encrypt application data that's flowing between the two, right? But that requires that you first establish that key on both sides. The other option is certificate-based authentication, which I know folks are, probably quite familiar with certificates who have done work in any cloud spaces. And certificate-based authentication basically says for a project, I can go in and I can upload a root cert, public cert, and say, I am going to have devices that are signed by the private key, that have certs that are signed by the private key of the certificate authority, and I'm going to have them connect. And in that case, you can actually do what's called zero-touch provisioning. So I don't have to go in and create a device before it connects and specify things and create the credentials and then load them onto the device. The devices can just come with certs on them. And when I upload the public cert, it's going to be able to verify, just like you do when you talk to a website and it's secure. It's going to be able to verify that cert was signed by the root cert, and that device will actually automatically get provisioned and connect. And we're actually going to look at doing that here in just a minute. But this initial handshake that happens at the beginning of the connection is a quite expensive operation, as I kind of alluded to earlier. And so you want to minimize that happening as much as possible. So we might not think too much about it when, we're in our browser and connecting to a bunch of different sites or calling a bunch of different APIs, because we have pretty powerful machines that are usually plugged into a wall. They're not limited on power. And so performing those operations is not a big deal. It's definitely worth it for the added security. When you have these constrained devices, you want to minimize the amount of times you have to do that handshake. And the issue is that if you have a device in transit, for example, like if you're in the back of a truck that's transmitting or transporting some, frozen food or something like that, your IP address is going to be changing all the time, right? You don't have a static IP. And by default, DTLS uses the IP address and port to associate connection information with another endpoint. And so one of the things that we've been working on recently is using what's called connection IDs, which is a extension to the DTLS protocol that basically says we're going to use a secondary identifier to associate this connection, so that when your IP address and port change, you can say, no, I'm still actually the same device you were talking to, and keep that connection in place. And I'll talk a little bit more about connection IDs down the line, but let's do a demo here. I'm going to start with the pre-shared keys and just show how that can work. So let me switch over to.
That's cool. Yeah, I always think of this too, like, because in a past life, I worked for a company that we had like smart meters, electric meters and things. And so I always think about that when they get installed and then they connect, they basically phone home and get provisioned and all their updates and that, because it's like, nobody wants to be sitting there clacking into a terminal, saying, yes, this device ID, MAC address or whatever, and mapping it. And nobody's got time for that. So
absolutely. Cool. All right. So let's jump in here. Like I said, I'm going to connect as this device here. And I'm just going to be using the pre-shared key credentials, which I've already loaded in. One of the things that, and just to be sure y'all can see my terminal here.
Yeah, we're seeing an agenda.
Yeah, cool. This is my secret agenda that
Yeah.
I've been driving this conversation. No, so first thing I'm going to do is use these pre-shared keys. So let's look at the test that I'm going to run. This is kind of a simple test, if you will, to demonstrate a number of capabilities of the platform. So first, we're going to perform that handshake. So when I just instantiate a new client with XK6 CoAP, that is going to perform that handshake and then give me a client back where I can send application data. I'm going to get on our hello endpoint, which just tells you who you are. So in this case, we should be device 1, which we're connecting as with that pre-shared key. We are going to post some data to our state service. So just say hello world. And then we're going to get our desired firmware version and start an observation on any firmware version updates there. Or sorry, observation on RPC, which this is actually cool. We'll show this for a bit as well. Yeah, and then we also have the OTA one. Cool. Okay, so we'll do this here in a moment. And that should be good. The other thing I wanted to mention is that we have a Docker image that we've created that has some a K6 build with XK6 CoAP and some other nice extensions in there that we use through a variety of our tests.
Oh, cool.
This is just to make it kind of easy to be able to run this locally.
We like the easy button.
Absolutely. Cool.
What other extensions do you use?
So in this case, we are going to be using, I think in the simple one, we use the timers. Extension. Yep. Which is nice just because we're establishing these observations. So it's not just sequential, right? We're like waiting and watching for things. So we use this, the set timeout down here is needed. It needs the timers extension, I believe.
Yeah.
I think that's actually now an experimental module because
right.
so many people were using it.
Oh, cool. Yeah.
Yeah, so you don't actually have to build it in special. It'll be there, but is experimental.
Awesome. Yeah, so we use that one. There are some other places where, for example, despite using CoAP for our devices, our API that drives our console and allows you to do things via our CLI, etc., is an HTTP API. So sometimes we'll have tests that mix actually doing something like creating a device and a PSK for it, and then using that to connect over CoAP. If we want to test out that path or something like that, or deleting a device and then making sure, it fails to connect or something like that, or disabling it. So we'll mix and match different protocols as well within a single one. I think that timers one, actually, we can just look in here what we build by default. Yeah, so I've just got that timers one in there. So it sounds like we can even drop that with newer K6 versions.
Yeah.
Awesome. Cool. So I am going to go ahead and run that. Let me grab this again and we can run it. So I'm just saying run interactively and then remove it when it finishes. And I'm mounting that simple JS script there. And then we're going to execute it with one virtual user. So just this one device for a duration of 5 seconds. And I'm passing in this end file, which has the PSK and PSK ID in it. So when it starts up, we're going to see those messages. So that hello device 1, we are sending the state. I believe this one, can't remember what we did there. But then we're listening for RPCs and getting our firmware version here. And so that's kind of showing all of the components in action. You'll see that completed successfully. Our timeout was longer than the 5 seconds I specified. So that's why it went longer. But we can do something like showing RPCs flowing through. So if we hop back over to the console, first thing we're going to notice is that our time this last connected has updated, right? So it connected a few seconds ago. So we can see that it was able to talk to it directly. We can see in LightDB state here. Let's see. I think I sent that, or no, sorry, I sent stream data. We sent this hello world 1144. That was just a minute ago. So we can see that's working. And then RPCs are really cool. What these allow you to do is in your firmware, be able to basically define a function that you can call from the cloud to perform some operation. So let's say, we were talking about light switches. Let's say you want to be able to turn on your light switch from the cloud, or turn on a light from the cloud. You could do that by, calling like flip switch or something like that and passing some parameters like flip switch, let's say dining room or something. It would seem like a constant. Dining. All right, cool. So I'm not connected right now, so that's not going to flow through. But let's go ahead and start that load test up again. And we're going to be listening for RPC calls. So we'll start it up. Looks like it's connected. I'm going to go over here, call this method, and then we get the response back from it. And you can see that flip switch method came in, and we just respond in this specific load test to just everything with an ACK message. But you can see kind of that RPC mechanism in action there. So this is another place where we might spin up a bunch of devices and then use the HTTP API to be able to do RPCs to all of them and make sure they respond correctly.
Right.
Yeah.
So that's interesting because you talked about CoAP in terms of REST. You said it was like REST. REST is typically entity oriented, but it looks like it's also procedural because it can do RPCs.
Yeah. So the way that the RPC is actually working here is we're essentially saying with the observation that the client establishes, and let me once again pull that up to kind of like put some code to what we're talking about. So this RPC here, it is essentially saying, I want to observe the RPC entity, and I want to be notified of any changes. And this RPC call is modeled as an update to the RPC entity, which is then sent, that state is then sent down to the device, and it responds to that update in state with the response to the method. So it's kind of like hacking that into it. But the reason why this observation extension to CoAP was introduced was because you do have a lot of this kind of like bidirectional communication from a server to devices in an IoT world.
And I noticed that you don't have something like a response time. It looks like you're looking at iteration duration time. Is that your primary metric for speed, basically?
Yeah. So measuring, we have a kind of common set of SLOs that we use on like our HTTP APIs, for example, and we measure latency for responses. When you're talking to devices, especially like when we're doing this RPC, when we're trying to evaluate our platform, it's actually a very difficult problem. And what really good responsiveness looks like is an interesting question, right? Because we don't control the devices out in the field. So if you make an RPC call and you never get a response for it, or it times out before a response comes back, is that an issue on our side, or is that an issue with the firmware on your device? And so that's actually one of the things that we measure. We can obviously trace all the way to that RPC call being made, leaving our cloud servers. But in terms of getting that response back, we really are, it's a bit of a black box looking out into what happens in the device. So we measure what we can on our side to make sure our platform is sending, and that if we receive the data that we're processing it correctly and getting it back to you. But in terms of like the latency here, this is, a factor of both our servers and your devices when they're communicating. Another thing that we look at a bunch, once again, going back to that discussion about the handshakes, is how often a handshake is being performed. So if a device goes offline and reconnects, are we doing a new handshake, or are we able to use something like connection IDs to continue that previous communication channel that we had in place? So there's a lot of different things we're looking for, as well as just like general load on the system. How many devices can we handle rolling out a firmware update to? if they all connect and try to download the firmware, are we amortizing the cost of doing that to make sure, that's both fast for the devices and not introducing unneeded load on our systems. Cool. The last thing I wanted to show here is that zero touch provisioning. And I really feel like it's kind of like the magical experience here. So before we got started, I have this tiny little tool called Certainly that basically will just generate some certs for you. And let's go ahead and show doing that. I'm just going to remove this search directory. And then we can make a new one. And you basically just tell it what your org is. So mine, or my project rather, let's go to project settings. So it's demo 5.2.5ca2af. So that's the org I want to use. And let's say I want to create 5 devices. So that's just going to generate the keys and certs for the devices, which they're going to use to authenticate and encrypt that communication. And then it's also going to give me the cert for the root CA here. And all I need to do is go into certificates here and add a client certificate authority. And I am going to root.cert.pem. That is not the one I want. Let's see here. Cases. Let me grab this real quick. Nice. All right. So we'll upload that. You'll see I just have some kind of silly information in here. And so it's just going to verify that any clients that connect to it have certificates that are signed by this root cert. And we'll jump over to devices. And I have another example here in the tests where we're going to use certs. So basically, when you want to use certs, if you just kind of zero out here the environment variables that specify the PSK and PSK ID, it'll use the certs instead. Another thing that I really like about this one specifically is in this K6 execution model, you can get the virtual user of the test that's running. And this is really great because we need to select different credentials for each virtual user because we want them to each act as a different device.
Different device, yeah.
Yeah, so that was one of the things when I was first looking at this that I knew we were going to have to solve. So being able to see that early on and saying, oh, yeah, you can get that execution context in the tests themselves. Super useful. So we use that quite a bit. So I'm just going to use my local K6 build for this. K6 run. Let me get back up to root. K6 run. And we're going to do VUs 5. We did 5 certs. And we can just say, what is it? D for duration. Is that right?
Mm-hmm. Yeah.
Yeah. Duration. We can do 5 seconds. And we'll use tests and certs. Hopefully I got all my paths correct here. And
what
is it? Just VU?
I
think it might be
dash dash.
Yeah.
You needed, yeah.
There is shorthand. I think it might. Oh,
yeah, there is a dash U.
Yeah. Okay, cool. So here you can see 5 clients connecting. They're all seeing what their latest firmware version is, which I haven't uploaded any, so it's just giving them back null. You can see that all created successfully. But if we go in here, we have 5 new devices. One of them, actually, we already had the correct naming. But they just automatically get provisioned and connect and perform whatever operations you want because they have certs that are signed by that root. So, for instance, if we did it again and just went ahead and deleted these. Oops. There we go. They should just do zero touch provisioning again, and we'll see them come right back up. So it's a really powerful way, especially if you are creating a bunch of devices, to be able to provision them really quickly and have them just provision when they connect. So definitely a highly desired feature of our platform here.
Yeah, no, that is cool. Because like I said, that feels like this would be great for like that smart meter scenario that I mentioned from my previous life.
Hmm.
And then, or even like, like when you get your internet service, right? They come out with the little device and then they plug it in, hook it into the network and, get that all provisioned. So then you can get your network connection and that. But yeah, that's really cool. Is that typically a lot of the uses that your customers are doing? Again, I guess I'm thinking of, what are the use cases? Who's going to be the one that's using that Goliath service to control this fleet of devices?
Yeah, so we have a couple different personas, and I think this kind of goes back to that idea of you know, talking firmware to firmware folks and talking cloud to cloud folks.
Yeah.
One of the things that I didn't show off today, but is our output streams. So basically, any data that can come into Goliath can also go out to other platforms. So a lot of our customers are using large public cloud providers, and want to eventually process their data there. But getting the data from the device to the cloud is the tricky part.
Hmm.
And so a lot of times it really depends on the customer, and especially the size of the customer, for who's kind of in the console doing these things. Could be a firmware engineer if it's, just firmware folks, and they may actually not be sending the data out anywhere else. They may be saying like, nope, we actually just need to monitor our devices. We don't really have end users that are consuming this data. And so, it's mostly firmware folks just interacting with the firmware that they wrote. On the other hand, you may have, someone potentially doing smart home kind of operations, and that data is actually flowing to their customers. So they may want it to flow all the way through to, let's say, AWS SQS, and then they send notifications to their users' smartphones. And in that case, we'd have cloud folks that may be going in and setting that up. And then in some cases, there's actually kind of more like operations type folks who are coming in and they're doing device management. And they may not write the firmware or write the backend for the application, but they are in charge of provisioning the devices, and that sort of thing. And so we looked at using cert-based authentication and doing that zero-touch provisioning, but maybe you have technicians that need to go out in the field and actually manually set up a device and do some sort of power on sequence. And in that case, they'd also need to be in the console. So we have a variety of different personas and a permission model that can accommodate a number of different roles there.
Cool. And then I guess the last thing I can go ahead.
Because you're dealing with a lot of devices here, I imagine that one of the issues would be how to gather that data. So I think observability might be even more of a problem for the IoT space than for other spaces. What do you use in that regard?
Yeah, so it really depends on the customer. If they have their own solutions, right? So they have an observability stack that they already use, then a lot of times they'll just send their data there. So, we have a lot of folks that are big fans of Grafana. We have some live instances of sensor data coming into like hosted Grafana instances, and it's a really cool way to watch how that's changing over time. So let's say you have some device that's like maybe a meter or some other sort of utility that you need to track the temperature and make sure it doesn't overheat. If you get that into your observability stack, then you can start doing things like alerting on it and dispatching folks when certain conditions are met and that sort of thing. So we really kind of like integrate with anything. But we also, have some of our own services, and like I said, we'll host things like Grafana instances and that sort of thing.
Oh, cool. All right. Well, so what's next with the extension? Is this something that anybody can use for anything else? Does anybody else have like a backend that uses the constrained devices that they
Yeah.
could use this, or is this
Yeah,
just Goliath?
I think that there definitely are some other IoT platforms that use CoAP. whether they use it exclusively or as, one of the protocols that they offer. And so I would definitely welcome them to try it out. Also, if folks have kind of like any internal servers that they use for testing or anything like that, they're another party that may be interested in this extension. We did open source it very early on, in my opinion. It's also, pretty small. So there's a lot of advanced functionality that we could add. And so we're looking to get feedback from folks, and definitely welcome folks to open issues, or if they want to contribute, we've got a contributing guide in the repo there for them to check out. So yeah, we're looking at kind of hearing from the community how they use it. And then obviously how we use it internally is going to be a factor for how we continue to develop it. Right now, it's allowing us to accomplish a lot of fairly simple use cases, but we'll continue to want to scale that up as we develop more and more functionality on our own platform.
Oh, that's awesome. Well, cool. And then, so how should people get a hold of you? I mean, just go to that contributing guide and then just interact through there if they want to help out or interested.
Yeah, that sounds great. Or you're always welcome to join us at forum.goliath.io if you want to post something there. We also have a Discord server that's linked from Goliath.io if you want to jump in there for some more synchronous communication if you want to chat with us. And then you're always welcome to reach out to me on any of the socials. I'm probably there usually at #Dan or at the ones that allow you to use a domain name now, danielmangum.com. So yeah, feel free to ping me anywhere, and I'm always happy to chat.
Awesome. Yeah. And I do have some of that information in the topic or the description for the video. So
Awesome.
Should have some of that there. So, well, awesome. Well, thank you so much for joining us and showing us the new toys that you just released on this last Tuesday. Much appreciated. And yeah, I don't know, Nicole, any final thoughts on your side?
No, it was really great. This is not a use case that I've tested very much. It's really interesting, the differences between this and testing a typical website or something. So
Yeah.
thank you for talking all of that out with us, and thanks for coming on.
Absolutely. Well, thanks for having me. I'm always happy to come back, and I appreciate the work that you all do on K6 and the rest of the ecosystem.
Yeah. Now we'll have to have you back on the Grafana office hours one of these times, and we can talk more about some of that the sensor data, seeing that like the heat and all that, and that.
Oh, for sure.
If
We'll
you could
definitely do
stay
that.
on, maybe let's talk about it.
There we go. Yeah. Nicole
Post-stream.
scheming.
Yeah. Yeah, definitely come back for that, and then we can also use some of the test output and send that over to Grafana as well. So
Nice.
we've got endless possibilities here. Let's just start doing this weekly. I'll just hop
There
on
we
with
go.
y'all.
Just
No.
leave it streaming.
Yep.
Absolutely.
Twitch 24 hours a day. So
Right.
there we go. All right. Well,
Awesome.
once again, thank you very much. And thanks everyone for watching. And then, we'll catch you on the next one. All right,
Thanks,
everyone.
everyone.
See you, folks.
Bye-bye.